Welcome to this module, and here today we will see what exactly as a differential amplifier. So, we have seen the op amp as an inverting, we have seen op amp as a non-inverting, and we have seen op amp as a summing amplifier. Now, let us see how the operational amplifier can be used as a differential amplifier. All right. So, if you come back to the screen. So, if I have a op amp in the following configuration, in the following schematic or following circuits, then what I see is I am applying input to the inverting as well as non-inverting amplifier, correct. I am applying input to the inverting as well as non-inverting terminal of the amplifier, inverting as well as non-inverting terminal of the amplifier. I have values R1, R2, right. In this particular configuration, how can I find my output voltage VO? First case is first I have to find the output voltage VO, the relation between the R2, R1, V1, V2 with respect to VO. Okay. So, you see these points, one is V minus, another one is V plus, one is V minus, another one is V plus. Now, what can I see? V minus equals to V plus. How? Because current into the op amp is 0 or because of the virtual ground concept, right. V 1 equal to V 2 or V minus equals to V minus V plus. So, I would be, so this one, okay. First we are considering this value which is I 1, then we will consider the value which is right over here I 1, okay. So, this value is nothing but what will be V 1 minus V minus. So, V 1 minus V minus divided by R 1, correct, and if I consider this value then it will be nothing but V minus, right, because here you can see here, then you have to see here. So, it will be V minus minus VO by R 2 minus VO by R 2. So, what is my V plus? My V plus here. Now, if I want to measure this value V plus, right, what will V plus? V plus will be, so you see here V plus, you have to consider this ground, you have voltage here. So, this is like a potential divider. So, V plus will be R 2 divided by R 1 plus R 2 into V 2, correct, because you see here V 2 is V and here is a ground. So, it looks like we are measuring, we have V 2, we have R 1, we have R 2 and we are measuring the V plus, correct. So, V plus would be nothing but R 2 by R 1 plus R 2, V plus would be nothing but R 2 divided by R 1 plus R 2 into V 2, right. Now, I know that V plus, right, because V minus equals to V plus. So, I will also put my value I 1 equals to this both values. So, V 1 minus V minus by R 1 equals to V plus minus V O by R 2, correct. This is the value. Now, if I substitute the value of V plus, if I substitute the value of V plus in this equation, right, what will I write? V 1 minus this value divided by R 1 equals to R 2 divided by this whole value, again we are substituting here in this place, right. So, if I solve further, what will I have? When I solve the complete equation, I will find that my VO equals to minus R 2 by R 1 V 1 plus R 2 by R 1 plus R 2 into 1 plus R 2 by R 1 into V 2. Or further I solve it, then my voltage output voltage will be nothing but R 2 by R 1 into V 2 minus V 1, correct. When you solve it further, you will get nothing but R 2 by R 1 into V 2 minus V 1. So, what is it doing? It is the differential amplifier. It is amplifying the difference of voltage at the output, right. And what is amplification factor? Amplification is done by values of R 1 and R 2. Amplification is done by substituting the values of or selecting the values of R 1 and R 2. What are R 1 and R 2? R 1 and R 2 are my feedback resistors. R 1 and R 2 are nothing but my feedback resistors. Okay. You got it. So, this is how my differential amplifier would work, that whenever I apply a voltage at both the terminals, voltage V1 and here V2 at the another terminal, my output voltage will be nothing but difference of the voltage, right, difference of the voltage into R2 by R1. This is the formula that I have to remember, and this will be my differential amplifier. This will be my differential amplifier. Okay. So, let us solve an example. Let us solve an example. So, for the differential amplifier configuration shown here, it is given that R1 equals to R3 equals to 10 kilo ohm. So, this is 10, this is 10, R2 equals to RF equals to 20, this is 20, this is 20. Solve for the output voltage, you have to find VO, right, the input voltage V1 terminal and input resistance to V1 terminal for 3 cases, V1 equals to 0 and V1 equals to minus VI2, right. So, let us see one by one. Now, because RF by R3 equals to R2 by R1, the output voltage is given by, it is very easy, right, VO equals to RF by R3 into this one VI1 minus VI2, right. If I substitute the value, 20 divided by 10 equals to 2. So, 2 times VI1 minus VI2. So, as RF equals to 20 kilo ohm and R3 equals to 10 kilo ohm, input resistance to terminals VI1 and VI2 varies as shown here, you can see here, right. So, what will happen, therefore, input resistance to VI terminal 1 is nothing but R1 plus R2, right. If you see this circuit, what we will find that the input resistance to terminal VI1 will be nothing but R1 plus R2, right. What is R1? R1 is 10, R2 is 20. So, it is 30 kilo ohm. Input resistance to VI2 when VI1 equals to minus VI2 will be, if we apply the Kirchhoff voltage law, then you will find that VI2 plus VI2 into R2 divided by R1 plus R2 divided by R2 equals to R3, right. If you see this circuit, you have to see this circuit, you will find this how we are solving. Also VI2, so when you further solve it, what do you get? VI2 by I2 equals to this particular value. So, therefore, the input resistance into terminal 2 after substituting the value. So, if I this is nothing but my input resistance of the terminal 2, right, VI2 by I2 is nothing but input resistance to the terminal 2, right, whatever the input resistance is. So, substitute, if we substitute the values, what will I have? 6 kilo ohm, I have value of 6 kilo ohm, right. So, this is how we can solve the problem for the differential amplifier, and solve few more examples by yourself. All right. Till then, you take care. I will see you in the next module. Bye.